calculations, where the primary thing was either a discrete or a continuous distribution, finding out the mean, variance or standard deviation or these kind of things about that particular distribution values, like this. So if it says a discrete random variable x as a probability function given by this, find the expectation of x, variance of x and the coefficient of skewness. So typically this is a discrete distribution where this is x, this is the probability of x. So it is a distribution first of all because sum of all probabilities is equal to 1. Now when I am talking of expectation or expected value of x, it is nothing but the multiplication and addition. 0.4 plus 0.6 plus 0.6 plus 0.4. So 2 is the mean or expected value of x. Now variance of x, either I can do it as expectation of x square minus expectation of x whole square, which means expectation of x anyhow we got it as 2. So expectation of x squared means you square up all these numbers. This is 4, this is 9, this is 16. So 1 into 0.4, 0.4 plus 4 into 0.3, 1.2 plus 9 into 0.2, 1.8 plus 16 into 0.1, 1.1. Oh, sorry, 1.6. 2 plus 3, 5. So expectation of x squared is 5 minus the expectation of x squared, x whole squared is 4. 2 squared 4. So variance is coming out to be 1. Now the same way you can look at the skewness, because the skewness for us is nothing but expectation of x minus mu whole cube. So either I do it this way, find out x minus mu directly here, right? Or you can expand it and you say expectation of, now that you have got the other two values, expectation of x cube minus 3 into 3 mu into expectation of x squared plus 2 into expectation of x whole cube. So this anyhow expectation of x squared we have calculated it as 5. Right, now expectation of x cube if you want to find, you can very well do it as this is cube, which will come out to 1 into 0.4, 0.4 plus 8 into 0.3, 2.4 plus 27 into 0.2, 5.4 plus 64 into 0.2, 0.1, 6.4. 7, 12, 14.6. This is expectation of x cube is 14.6 minus 3 into expectation of x is 6 into expectation of x squared we have got it as 5 plus 2 into expectation of x whole cube 8. So this is 16. 14.6 plus 16, 30.6 minus 30. So we are saying that the skewness is 0.6. This is not coefficient of skewness, this is skewness. Skewness is 0.6. So coefficient of skewness is nothing but skewness divided by the standard deviation whole cube or variance to the power 3 by 2. Variance we have already got it as 1. 1 to the power 3 by 2 again is 1 only. So you can very well say that the coefficient of skewness is 0.6. Once the coefficient of skewness is 0.6, probably you may say that it is a positively skewed kind of a distribution. So with the discrete, the typical question that can come out from this particular chapter is mostly to do with this. Either asking you to find out the expected values, the variance, the standard deviations, the skewness, any of these kind of an items. Now the other one is, let's look at the next question then, the continuous part. A continuous random variable y